These next two problems are very related, so we're just going to knock out these two birds with one stone. So question 43 is asking, how does the ionic radius compare with its parent radius, the regular non-ionized, the regular neutral atom radius? So metals typically lose electrons and non-metals typically gain them in an ionic. Well, we haven't gotten there, so let's just say here's a metal, typical metal M, and when it loses an electron, and they'll form what we call cations. But oftentimes that whole energy level, I'll use A. Perfect, this is why I'm doing it together. All right, so let me back up here. So sodium is a metal, right, and it's the parent atom of that ion. When it loses an electron, it'll turn into a sodium ion. So it's sodium with 11 electrons. It's got 2 in its first, the 1s orbital, the first energy. It's got 8 in its next one with 2 in the s and then 6 in the p's. And then in its third energy level, we know they're not in orbits like this, but this is how it's just much easier to see this way. That's sodium's valence electron. It has 1, that's it, and it's in the 3s orbital, so it has 1 of them. All right, once that thing is gone, right, it becomes a sodium ion. All right, we put this plus sign there because it has lost an electron, which are negative charges. So the 11 protons it's always going to have 11 protons, is going to have one more positive than a negative. So sodium now has 8 here. There's your 2 electrons in the 2s, and then there's your 6 electrons in the 2p orbitals, right? 2, 4, 6. Okay, so what just happened? We just lost this entire energy level that was there, right? So it's often going to be the case. That's going to be the case. Now, even if it doesn't, the 10 remaining electrons are going to have a bigger piece of the remaining of the nuclear charge. So we'll see that when we get to D. All right, so how does the radius, this is always smaller than the parent atom or the neutral atom. Okay, let's take a look at another one. Oh, so here's the nonmetal. So nonmetals will typically gain electrons. So when you gain electrons, well, what do you think? You apply the same. Here's sulfur, by the way. It's often going to gain 2 electrons to try to achieve the noble gas configuration. We call that the octet rule. We're going to get to that in our next chapter when we learn about chemical bonds. All right, so sulfur. Okay, so its valence electrons are in n equals 3. This is a 3p section here, and this is a 3s. So the s and p's often make up the valence electrons. They're the outermost electrons. So sulfur, I'm going to draw all the dots there, all the electrons. Well, we know their valence electrons are in the third energy level, third shell, n equals 3. Right? It's going to have 2 in the 3s orbital, and then it's going to have 1, 2, 3, 4. 4 in the 3p orbitals. Right? So it's going to have 6 valence electrons. 1, 2, 3, 4. It's going to have 6 valence electrons. We already know that also because it's group 16. That second digit will tell you the number of valence electrons. All right, in any case, it's going to, in order to become a 2 negative ion, which is what's in the problem right there, it has to gain or lose electron. You can't change the number of protons. All right, sulfur is always going to have 16 protons. Sorry. All right, always going to have 16 positives. Now, it has to gain 2 electrons to become 2 negative. So we got the same number of energy levels. All right, now this time we have 2 more electrons join the party. All right, 2 more electrons join the party. Do the other electrons like that? No, they don't, because every one of them wants a piece of the 16 action, the 16 proton action. All right, they don't want to share. Right, and these inner electrons are just shielding the outer electrons. So the anions, we call these, by the way, negative ions, they're going to be bigger. Right? They're going to be bigger because the each electron in the atom is going to get less of the 16 protons. All right. In other words, they're attracted less now to what they're attracted to, which are the protons. So if there's less attraction between the protons and the negative electrons, they're going to be farther apart because they're less attracted. So they're going to be bigger. All right, so there is, now we don't have to answer that in 43 because 43 is just asking about metals. Metals don't lose electrons typically. I'm sorry. Oh, that's the opposite. Metals typically lose electrons. B, which particle has a larger radius? Now anions, right there. There's your answer. Let me circle this. Larger. Parent, larger. Cations, when they lose electrons, they get smaller. When you gain electrons, they get bigger. Well, that's very logical. You can just think of it like that. All right. So, same reason. Pick a different color. All right. The iodide ion, it just gained electrons. So iodide is a halogen. It's right over here. All right. Gains one more electron, turns into that isoelectronic with noble gas. It's going to be bigger, and then metal, aluminum is a metal. You just know that from general knowledge. So when you lose, you've got to lose electrons to become positive, right? Because electrons are negative charges, and then you're going to end up with more protons, which are positive. All right, so the parent atom is always larger than the cation, the positive ion, and the anion is always larger than its parent because it has gained electrons. All right, let me just make this clear. Sodium is the answer. Sulfide anion is the answer. Anions are larger than the parent, and then the parent is larger than the cations. All right, these are your answers.